My name is Arian Khan, and I'm going to be solving these three vector questions. Okay, so the first question we have here is a triangle ABC has vertices A, B, and C, which are the points. And we have to show that the triangle ABC is a right triangle, and we have to measure the two acute angles. So first, but what we have to do first is find the magnitudes between each points. So what we want to do is do x2 minus x1 and then plus y2 minus y1 and z2 minus z1 and then square all of that. So it'll look like this for AB. 3 minus -1, and then we have -1 minus 3 and 1 minus 4, which would just all be okay. Now we just put this into something to find the magnitude, which is 4 squared plus -4 squared plus -3 squared. And then we put this into a calculator. Square root of 41. So that is the magnitude of AB. Now we just have to do the same thing for AC and BC. Okay, so for AC we did 5 minus -1 and then 1 minus 3 and 1 minus 4, and we got 6, -2 and -3, and then for the magnitude we got 7. And for BC we did 5 minus 3, 1 minus -1 and 1 minus 1, and for that the points we got 2, 2 and 0, and for the magnitude we got the square root of 8, which is also 2 square root 2. Now we have to prove that it's a right triangle, so we can use a squared plus b squared equals c squared. I guess the easiest way is just to guess and check and put the three magnitudes in for a, b, and c. 2 square root 2 squared plus the square root of 41 squared is 49, which that squared is just 7. So we have bc squared plus ab squared equals ac squared. We've proved that it's a right triangle because ab squared plus bc squared equals ac squared, which is a property of right triangles, I guess. And now to figure out the angles, or like the two acute angles, we can use SOHCAHTOA because SOHCAHTOA works for right triangles. So if we have theta here, we could do opposite over hypotenuse for sine, so it would be 7, which would just be 66 if you round it. To find the other, we could just do, since the triangle has 180 degrees, minus 66 from that, and minus 90, because we have 90 and 66. We get 24. Therefore, the other angle has to be 24. So the two acute angles in the triangle are 24 up here and 66 down there. Okay, so the second question that we have here is 2x plus 3y equals a and -x plus 5y equals 6b. And we have to express x and y in terms of a and b. The fastest way, most efficient way, is using matrices. Okay, yeah, so to make this number a 0, we can do 2 row 2, which would be -2, minus row 1, or actually plus row 1, so it'd be -2 plus 2, which would give us the top half, one of the numbers in the top half 0. We could do 13 R1, so this would be 39, and we could subtract it by 3R2, which would make this 39. So now, since we have one number in pretty much each row, we can show that this is x and this is y. So it's 26x equals 13a minus 3a minus 36b. And we can also find y, so 13y equals 12b plus a. Y equals 12b divided by 13 plus a over 13. Yeah, and that's how we can express x and y in terms of a and b. Okay, so the last question we have is to find the magnitude and direction of all these vectors added up. So since there's 4 triangles in the hexagon, the triangle has 180 degrees in it, so if you do 180 times 4, it's 720. So the whole hexagon, if you combine all the angles, it should equal 720. So if there's 1, 2, 3, 4, 5, 6, there's 6, I guess, normal angles in it. So if you do 720 divided by 6, you get 120. So we know this angle is 120, and as well as this one. Yeah. And we know the side length's 1 and 1, so here we could do cosine law to figure out this magnitude. Okay, so after doing cosine law, we figured out that the magnitude of this length is square root of 3. So now to figure out this length, we need a couple angles. Because both side lengths are 1, we could assume that this could be 30 and 30, but to make sure, we can do sine law to figure out these angles, and then we can subtract whatever this angle is by 120 to figure out this angle. Okay, so we figured out that this angle is 30 and this is 30 as well from sine law over here. Next, we can, to figure out this angle, it's 120 minus 30, which is 90. So this is a right angle. And since this whole angle would be 120, and it is divided into 4, and one side is already 30, so 30 times 4 is 120. So we can assume that all the other angles are 30, 30, and 30. And to figure out this angle, since we have 90 and 30, this one has to be 60. So this is pretty much a special triangle. So it'll look like this: 30, 60, and then here we have square root 3, 1, and we have to figure this out. Okay, so we figured out for this magnitude by doing SOHCAHTOA. So we have AD, which is 2, and one way that we could do it is AB plus AE would equal AD, because if you take this like the tail and the head and you translate it down, you would equal AD. And then if you also look at AE plus AC will also give you AD if you translate the vector AE or AF. So now if you just rearrange the equation, you take this, all of them out, and you just have AD plus AD plus AD. And since all the values are 2, it's 2 plus 2 plus 2, which just ends up equaling 6. So the magnitude of all the vectors combined is 6. Now to find the direction, the easiest way that I like to do is make a compass and have AB going east. So AD would just be 60 degrees south from east, so it would just be east 60 south, and when you add all the vectors up, it would end up looking like 6 units east 60 south. So those are the solutions for the 3 vector questions with thorough understanding, and I hope you found this video useful. Thank you.